Hello everyone, welcome to the Mammothon Tutorials. I hope you're all excited to get started. We're going to start off with a short introduction. So first of all, I wanted to introduce myself. I'm Rebecca, I'm the Programme Manager for the Mammothon from Encode Club. And I'll be in contact with you throughout the programme, and if you have any questions at all, then I'm the person to ask. So just send me a message on Discord or by email, and I'll try my best to help you out in any way that I can. So at Encode Club, we're an education community. We help you learn, build and forge your careers in emerging technology. We do this through educational events like hackathons, public education series, boot camps and accelerators. And we hope those of you who are new and joining us from the Mammothon will stick around in our community as you build and grow, because we're really excited to be part of your journey. So let's talk about the Mammothon. It's a really simple process. You have 28 days to build and ship your projects and be in with a chance of winning part of the $250,000 prize pool. So that is huge. The prize pool is going to be split evenly between the top 10 teams across all idea tracks. Now, this is where the Mammothon is a special event. In the Mammothon, you don't have to come up with your own project concept. There are Celestia Ecosystem partners who have shared ideas on what they want to see built on their tech stack. So they've given you all the resources that you need to succeed. You can build unstoppable apps, you can craft on-chain worlds, and you can upgrade the internet. The last thing to mention about the Mammothon before we move on to the tutorials is that in order to participate, you must be in a team of 3 to 5 devs. If you've not already, please read your emails for information on how to build up your team or how to register the other team members in your team to make sure that you qualify to compete in the Mammothon. When we launch, we'll have over 30 ideas, which means a few more are going to be announced very soon, so keep an eye out for that. And each one comes with a matching tutorial. This is really important. We want to make sure that you have everything you need to start the Mammothon so that you succeed. In these workshops, you're going to get all the essential technical skills that you need, and you're going to have the opportunity to ask questions and clarify requirements with each of the idea partners. Okay, so that is everything from me. Let's jump right in.
My name is Scott. I'm the founder of Argus Labs, and today we're going to be showing you how to build your on-chain worlds in record time with the World Engine. So a quick introduction for all of you who might not know about me or haven't really talked before. My name is Scott. I started Argus back in 2022, and before I started Argus, it is actually not like Argus wasn't the first time I was working on on-chain games. I actually had a long history with on-chain games, and it's like actually how I got really my start in the industry. By building a game called Dark Forest with my friends back in college. And so Dark Forest, for those of you who might not be familiar, is the first fully on-chain game on Ethereum built on, using zero-knowledge proof technology that ended up defining the category. This creates this whole like, oh yeah, nice to meet you too, Mohammed. Yeah. And so the Dark Forest ended up becoming this like, kind of like a controversy in a sense, because back then, like, we now take for granted that we have things like rollups, etc. But back then, rollup didn't exist yet. And so all we had was like side chains and like, of course, the Ethereum L1 itself, which again have issues with like, handling all these transactions with Dark Forest. One of the things that we actually had was like we launched Dark Forest on like XDAI, which is now called Gnosis Chain, and it immediately filled up the entire blockchain, where like 80% or 90% of the block space was just like Dark Forest transactions. And like I kind of remember vividly where like people were literally like trying to use the chain, and they were like, oh, like the chain is like clogged up, and like no one knows like what's going on. And it turns out it was like people was just like trying to play this like space exploration game. And so that's really how I got my start in like this whole like, rabbit hole of on-chain games. And like, almost 3 years later, still building on like, these like concept of like fully on-chain games. And so like the key thing that I realized to the problem that we have and why we don't see a lot of on-chain games, even like like years after Dark Forest, was like very simple. As it turned out, it was like one simple word, which is speed. However, every person or every blockchain loves to talk about speed. Like these are like one of the main things that a new rollup or a new blockchain to like a new rollup or a new blockchain would like talk about every time like they're like trying to like sell their blockchain to like basically like get people to use it, right? It's like, oh, like our like chain is faster, etc., etc. But I think like there's so much nuance to the word speed that most people don't actually explore when they're talking about blockchains. And so when people talk about blockchain speed, I actually think about this in like 3 different layers, right? Especially for how it relates to computer games. And one of the biggest continuous area of research, even in like traditional video games, are performance. Like, if you ever work with like Unity or Unreal Engine, they spend a lot of time actually thinking about performance of the game engine. So even like the most state-of-the-art game engines out there who is like powering AAA games, like those software are still in this constant pursuit of performance optimizations. And these are already software that is like purpose built for like supporting game use cases. These are not like general purpose, like, software SDK. No, these are game engines that are already fine-tuned for running games. Even those software, those engines are constantly fine-tuned every day by these like, large game engine companies to even make it even faster to like be able to support more expressive and more complex games. And the 3 major ways that these performance optimizations are like measured in video games is ticks per second, entity updates, and action latency. And to make sure we kind of like understand every single piece of this, I want to like kind of just start by focusing on the first 2 first, because this is like what is like most important, not only on the client side, but also on the server side for all genre of game, regardless of like whether it be like a first-person shooter or it's card game, or it's even like, I don't know, a simple board game. And some of you might already be familiar with like, like even like these like simple games out there, like, for example, Agar.io, which is like if you guys haven't played Agar.io, I think you're missing out in life. So I highly recommend checking it out. But like, yeah, so Agar.io is this like insanely popular casual game that bored high schoolers, like and college students all around the world, have like played before when you're just like, bored in lectures or whatsoever. And this is like, as far as it goes, like one of the simplest multiplayer game that you could build as like one of your first projects. And even then, Agar.io has 20 ticks per second, right? And then it can support 200 of concurrent players in the same room. And if you want to think about it in blockchain terms, like 20 ticks per second means that there is a block or there's a state update happening at 20 times per second. And so you can, if you translate it into seconds, you would need to have like 50 millisecond block times. So every 50 millisecond, there needs to be a new block. This is pretty much impossible with like a traditional like layer 1 blockchain, because you need to have consensus, and like you can't have consensus at like, less than like, a second, or like, even like, I mean, like you can make trade-offs, and then like, even then the best you could really have is like 500 millisecond, because there's like a lot of these networking like bottlenecks, etc. And even then, like you're also making the trade-off of like how many transactions per second that you can process. But like what you realize about this is like the most simplest multiplayer game out there require you to have like even faster block times and even more transactions than like what the state-of-the-art blockchain, like general purpose blockchain currently have. And like if you want to see it in like from the perspective of rollups, we actually are not even close to being fast enough. Like these general purpose rollups are just like not close to being fast enough to support the simplest of simplest game, like real-time game like Agar.io out there. So if you look at the stats for Optimism and Base, they have like 2-second block times, and with the maximum theoretical TPS, this is like assuming that you have like the simplest of transactions, which are like only token transfer, etc. Assuming there's no DA bottlenecks. All of this, like you process 1,000 transactions per second, which again, if you check on the previous slide, is like pretty far like from like where we're trying to get to. And again, this is only for a single room. Like you have to again remember that Agar.io is not like only like a single room. There are multiple rooms out there with like thousands of players playing at the same time. And so in reality, in practice, it would actually require you more than tens of thousands of transactions per second to be able to support like a production scale Agar.io deployment. And so that is like really the first half of the puzzle, and we still haven't even covered the other half of the puzzle that basically, like if you're building a multiplayer game, is like the most like hotly like debated topics between the developers, but also with the players itself. Like I play a lot of video games, and like these are the things that people would like complain about every time, which is action latency, right? So if you've played any mobile games out there, let it be a mobile game or Minecraft, League of Legends, or Counter-Strike, all of these multiplayer games have this concept of action latency. They have this concept of ping that you might be more familiar with. And all of these games require low network latency to be able to work. Like these games will not function with like network latency above like 200 milliseconds. Like all of these games require the like users to be close enough to the physical server, to be remotely playable. If you have if you have a latency that is like above 500 millisecond, the game will like disconnect you because it would be like literally unplayable. That is like the state of like where multiplayer games are. And these are not just like a nice to have. These are requirements, because if you have bad ping, or like you just like don't have good enough network latency between your players and like your game server or your game backend, players will complain. They would constantly talk to you about like how like why is like my ping so high even if I have a good internet? Why do I get constantly getting kicked out of the game? Why am I glitching through the map? And so it is a very real problem where players out there really do need this to be able to play these games, like regardless of like what mobile or like PC, and like whether it's like more slower pace or faster pace. This is like a key ingredient that is very much needed in like most modern real-time games that we play in the real world. And you kind of like now have to like really take a step back, right? To really understand like how problematic this is with on-chain games, you kind of like have to internalize how complex the transaction supply chain for an on-chain games currently are. And the way to picture this is like I like to use this diagram to really kind of see like the step-by-step that a blockchain transaction needs to travel before it even reaches the sequencer, and like getting updated on an indexer and getting sent back to the game client. And the way that we can even simplify this even further is by using this concept called a time to action, right? And the time to action is the measure or the time that it takes for a player move to be recognized. And this is really created with like three main like pieces of measurement. First is the latency between the client and the server, and like the second part is the time that it takes to compute the state transition. So this could be like something analogous to a block time, and like last but not least is the time that it takes for the network or the data to travel from the server to the client, right? So from a blockchain node to the client. And if we want to kind of like really understand what really kind of influences this like key measures the most, and like there's like one rules of physics that really defines this and we can't really violate, which is the speed of light, right? if you like data simply cannot travel faster than speed of light. So however you might like want to like implement like your software, how fast you like have like your blockchain is, at the end of the day, one of the key things that you cannot make faster is the speed of light. These are the grand constant of the world that you simply have to work around, which we'll kind of like learn about how we're going to do it later. And so first, let's try to understand like how much it would take for like, like from all these like step by step, from the client to the blockchain node, from it's getting applied, etc., and back to the client, how much would that take, right? And so first and foremost, like from the game client to the full node of like, let's say a blockchain, this is going to be dependent on like your node location based on like your where your players are, etc. And then afterwards, those like nodes need to gossip those like transactions to the sequencer, which would probably take around like 200 millisecond. And afterwards, the sequencer, assuming let's say like a 1 second block time, would send that new block back to the full node. And then the full node would then like and then like an indexer, which like again, like if you're using let's say like a fully like a smart contract based like on-chain game framework, it would have an indexer of some sort to be able to cache like the data. This will take like like even more like latency to kind of just like fetch the data one by one from the full node. And like let's assume, you can assume like let's say like a 30 millisecond latency between these two services. Again, like for each network request, that's an additional then the additional kind of like latency on top. And then afterwards, the indexer would have to store that data into like, let's say a SQL database, or maybe like some sort of like, in-memory storage. That is another extra like latency that they need to travel, which again, they can't really make any faster because it is bound by the speed of light. And only then, after they've already traveled through all these like, networking calls, network steps, etc., then those new data from the node, from the indexer, would be able to be transmitted back to the game client, which would again be dependent on where the game client or the player is located relative to the server. And again, we can kind of basically now fill in the blanks here in terms of like the different pieces of like how it's going to take. So the client server latency is going to be dependent on player, and state transition delay is just like the number that you can add up. So in like here, so you have 200 millisecond with the 1 second block time with the network call for data fetching, and also SQL database storage. And then you can now add all of those up. And again, we kind of assume a very conservative estimate here of like, let's say like they have like 2 network calls for the indexer, etc. And then that alone, for the state transition, remember, we haven't even added up the client server and like the server client latency yet. That alone for the state transition, for computing the updates for the player for the game state, that alone would take 1.5 seconds. And remember here, like this is like still like one piece of the puzzle, and we're already so much slower than what real-time game requires. Remember, the real-time games needed a fraction of like a millisecond, right? So a fraction of a second. We need like a 50 millisecond state transition delay. So one like current blockchains or current like on-chain game like architecture, like the way that people have been like building it, is like orders of magnitude slower than like where we need it to be able to support a simple game like Agario. And again, we still have the other problem, which is the client server latency that we need to figure out, which again is bounded by the speed of light. And why speed of light? And like how do we actually make things faster? And the answer here is simply like location and proximity to the blockchain node or to the server. Some of you might not be quite familiar with like how the internet works, but the internet is really just a giant piece of network of wires, right? There are just data traveling across, different regions, different countries, on land, under the sea, using these like wires that are connected to each other on different data centers, and these are all carrying your data. And all of these data is traveling at the speed of light, or close to the speed of light. And like the speed that you're able to send those data is bounded by how far you are, right? So because like again, we cannot make the speed of light faster. The only way that you can actually be able to deliver your data faster and have like a lower latency is to be physically closer to the server or to the blockchain node. And so to give you, so to give you like a quick estimate or like kind of like a quick image here, imagine if you have players that are spread all over the globe. Because again, if you're building a game, you don't really want to only have players from one region. You want to have players from all over the globe. But let's say you have a blockchain that is hosted in like US West or like in Oregon, usually if you're using on AWS, etc. All of those data needs to travel from each of your players' region across the world into like the other side of the world to North America, to the United States, and those will take you insane amount of time. And so to just give you an idea here, is this like a latency test that that I made, and you can see that like the round trip time that it takes to travel between these regions would like take up even like 200 milliseconds, depending on where your players are. And again, these are the key things that are going to be able to limit your like your player, right? And again, remember, for Agario to be able to be playable, for all these like major games to be playable, they require you to have 100 millisecond latency. So for if you only have a single location or a single deployment of your game in a single region, most of the world is not going to be able to play the game smoothly, simply because they are physically too far from the server to be able to have a low enough like network latency. And this is why all major games out there have regional servers. They have like, you know, let's say if you're playing from Southeast Asia, they connect you to the Southeast Asia server. If you're in like California, they connect you to the US West server. If you're in New York, they connect you to US East server, and so on and so forth. However, classical blockchains does not support this. And so if you try to like build a fully on-chain game on, let's say, like a rollup that has their sequencer located in like US West, and you're, let's say, based in like Indonesia, where I'm from, then you would have to add 200 millisecond latency to the already terrible like, you know, like action latency that we already have, which is like 1.5 seconds, which again already bad onto itself, and this will just make it even worse, right? And again, remember, if you go to Reddit for like, let's say, like these like Counter-Strike games, or like, you know, or like these like FPS game or any other game, like mobile game, etc., people would complain if they have 100 millisecond playing. Like this is not even 200 millisecond. It's not one, like all these things added up. It's 100 millisecond. People would complain if like the game is that slow. And so like, just imagine if we try to build a game that has real-time performance requirements in like a classical blockchain, then like, I think every players would go insane. That is like, that is basically the state of like the art in fully on-chain games right now. And that's like why all on-chain games are like extremely simple, or have like extremely basic mechanics, for the simpler reason that like otherwise everyone would go insane trying to play the game. And so the question here is like, are we fucked, right? Are like, you know, do we have a solution for all of this, right? And so I think the obvious answer here is like, yes, because if we don't really have an answer for this, I wouldn't be talking to all of you guys. And so this is like why I created the World Engine. From like the learnings that we have, like from like me building like Dark Forest with my friends, I kind of like learn how hard it is to build like a game on chain, right? I know like building like normal applications or like normal basic DeFi apps, building NFT marketplaces, building simple token transfers on a blockchain is already hard enough, because like you have to learn these like new like programming language, you need to like learn the specific nuances of the blockchain, etc. But beyond that, like now you have to deal with the sheer complexity of building like a game logic on top of it, right? With like on top of these like smart contract systems that are just like not designed to support it in the first place, right? Smart contracts have been like, you know, again, like when originally designed, it was like specifically targeted like, oh, like people imagined they would use this for like financial transactions, for like, you know, trading, etc. they've never really taught someone to actually try to build like, you know, a game on top of it. And that's like why it's like so hard to build, like, or like sometimes you require a lot of these extra engineering work to just make the most basic of like on-chain games to work, even with all of these smart contract frameworks, right? And so we designed a world engine to be anything but that, right? We want to make sure that anyone who's building on the world engine doesn't have to be a cracked blockchain engineer, right? So let us do all the headaches of like having to deal with the blockchain so that you as a game developer can focus on building an actual fun game instead of trying to like figure out why Solidity is like having this, you know, stack to deep error that is constantly haunting everyone, or like having to worry about how to scale your rollup or how to scale your blockchain, which again, game developers don't really want to like worry about, right? If I build a game, I just want to make sure that everyone can play the game. I don't need to like, you know, like tell people that hey, they can't like play the game because our blockchain doesn't scale, or like we don't have enough capacity for more users, right? And last but not least, of course, is that we want to make sure that game developers are able to use any game engine that they want to use. Again, game developers are already familiar with like, you know, their tool of choice. They might have used Unity, Unreal, etc. We want to make sure that they're able to use them instead of being forced to use like, I don't know, JavaScript, because that's like where most like, you know, blockchains only have like, you know, integration support for. They have like integration support like JavaScript with React, etc. But like, no, like game developers already have these engines that gives them so much power to build like cool, like and beautiful games. They want to be able to use that. And so that's like why we make sure that the world engine is able to integrate with any major game engines out there. And we have like a slide, literally just like all the logos of the game engines that world engine supports. But again, what is the world engine, right? Like what it is that allows it to have all of these like cool, like, you know, benefits and like unique advantages. And so to be able to understand like how we're able to achieve and solve these problems with latency in the world engine, we first have to understand the world engine sharded rollup architecture. If you see any like classical rollups out there, you'll probably be familiar with the diagram on the left, where you have like this like settlement layer, which could be an L2 or an L1, and you have an like a rollups that settles on top of it, right? And like these rollups would have a 7-day challenge period, and so if you want to like go to different rollups, you would have to like basically like wait 7 days, and then like, you know, and only then you can like go bridge again to the other rollup to be able to send a simple message. With a world engine, every single like, you know, like you're able to have like multiple games, like multiple game shards, multiple like, you know, almost these independent runtimes existing on a single rollup cluster that connects and coordinates with an EVM base shard where you can deploy smart contracts for NFT marketplaces, etc. But having all of these independent like game logics be executed isolated from each other on their own like, you know, runtime shards would make sure that you're able to add more game shards if you want to scale your game, and to make sure if like one of your game shards have a lot of users, have a lot of transactions, it does not affect the performance of your other game shards, nor does it affect the performance of like the smart contract transactions that is happening on the EVM base shard. And this is like where like the multi-runtime asynchronous execution model that we invented comes into play. And so in a traditional rollup, you would have these like one EVM runtime. Again, the EVM is like slow. There's a lot of like performance bottleneck, blah, blah, blah. And like you already know this spiel, right? You would have to take 1 second to just like compute the most like, you know, limited amount of computations on the EVM, like Solidity smart contracts. And that's like basically how fast you're able to go. And like the faster you go here, the more compromise that you're able to, that you start having to make. And that will also cause more headaches for the, you know, the team maintaining and running your chain, like let it be a rollup as a service provider or even yourself. With the world engine, we keep the EVM shard as its own, and like, you know, you can process the smart contract normally. However, all of your game logic will be executed in its own dependent game shards. They're able to be to run much, much, much faster than a traditional EVM blockchain. And so when the EVM blockchain can only process like at, you know, 1 block per second, the game shards is designed to be able to run at 30 blocks per second. And this allows you to build games like Agar.io that has like these like real-time requirements because the blocks are simply so much faster. And again, we're able to achieve this with a lot of really clever optimization on the memory level or on a state management level that optimizes for like cache locality. And so that is like what the world engine allows you to do that the normal rollup will not be able to be able to provide you seamlessly. And again, with Agario, the target was 20 blocks per second, and then 4,000 transactions per second, which you are able to easily support using a single game shard. And like, yep. And so now we've solved 2 pieces of the puzzle. So we no longer have to worry about the ticks per second. We no longer have to worry about the number of entity updates per second, because we can spin up more game shards if we ever need to, and we have like these game shards running at 30 ticks per second, which is like faster than the requirements that we have for a modern real-time game. But now we still have this like one problem with action latency. With action latency, again, the problems are the speed of light. So the only way you can like fix this is not by writing faster software, but literally figuring out how we can bring the blockchain closer to the users. And so again, this is like how like an on-chain game would be implemented like currently today with a traditional blockchain and indexer architecture. With the world engine architecture, we simplified this significantly. We eliminated the need for we eliminated the need for an indexer. We eliminated the need for a full node transaction gossip. So that eliminates another extra hop. And then we eliminated the need for the block sync latency as well. That it saves us even more time. And then like that is like what allows the game shard state optimization strategy to even be possible in the first place. We remove a lot of these like extra network calls that requires the data to travel even further, simply by the virtue of having to hop around on different parts of the world, trying to like, trying to gossip the transactions, etc. We reduce the amount of moving components to make sure that the data does not have to jump across the world again and again. And by doing this, we're able to significantly reduce the state transition delay from 1.5 seconds to 30 milliseconds, and putting us under the budget that we give us for a game like Agario. And now we have solved the state transition delay issue, but we still have like the client server latency like piece of the puzzle that we haven't quite addressed yet. And this is like the part where the sharding system actually works very well in like solving at the same time. And so in a basic rollup or traditional rollup, however you want to call it, you have a single like sequencer, you have a single like blockchain node that is processing all of these transactions, right? And so you can't really create multiple of these, because if you have multiple sequencers, then that would create multiple blockchains, right? In like a traditional, like let's say like Optimism or Arbitrum stack setup. And again, sure, you're gonna like spin up different L2 and L3s, but then like you would have to deal with the challenge period. And so for most instances, like all fully on-chain games operate from a single sequencer, where players would just have to like spend 100 and 200 milliseconds trying to like talk with this like sequencer that is like halfway across the world. With the world engine, you're able to spin up the shards in different locations all across the world, which allows you to reduce the latency from the client to the blockchain node to the game shards, and at the same time ensure that you still have the interoperability benefits that you would expect from like being a single rollup instead of like being completely independent rollups. So again, you don't have to spin up separate rollups. Like the users does not have to like go through this challenge period to communicate across like one shard to the other. We design the communication like architectures like to be like asynchronous by default, which allows you to really geolocalize these shards and like bring the game shard sequencers closer to your users. And this is like how we're able to achieve faster time to action with the World Engine geolocalized game shard feature. And again, you can do this to deploy your game shards to any part of the globe you want, where there is a data center, of course. And like this allows you to give your players low network latency from wherever they are. And at the same time, this actually creates another extra layer of like decentralization that a lot of people are not thinking as much about with rollups, which is geographic decentralization, right? Because currently, if a rollup like sequencer, let's say in like US East 1 is like had an incident where like US East 1 like maybe like caught on fire, etc., the rollup would have to go down and like basically shut off. But with the game shard, you basically have these like redundancies. You can have these like game shards on different data centers, different sides of the world. And so if there is like, let's say like, God forbid, like an incident in like, North Virginia where US East 1 is, there are going to be other game shards out there able to continuously serve your players and like continuously like play the game until like the US East 1 game shard is able to recover. And so that is like another layer of decentralization that you get from the sharding architecture that you might not be able to get from a traditional like single sequencer architecture. And like, all of this added up, we're able to save significant time all across the networking layer. So you save like 70 milliseconds on a client server latency. We save almost like 1.5 seconds on the state transition delay. And we're able to also save time on the server client latency. And like added up, this is like all under 100 milliseconds, allowing us to have these like seamless and fluid movements for the player for modern real-time games. And so like, yeah, now we have solved all the major pieces of puzzles that we would expect from a modern, modern real-time games, allowing fully on-chain games to not only be this like simple, very basic game. You can actually build complex real-time games that typically people would have thought it would be crazy to be able to build on-chain. And like with the World Engine, all of those things are no longer like a fantasy. It's like now as easy and like to build as you would to build a normal game server. And that's like what we want to do with the World Engine. But the story doesn't really end there, because at the end of the day, I think building a game should be as fun as building I think building a game should be as fun as like playing the game itself, because it's really hard to really kind of like be motivated building your game if like the dev tooling, the compilers keep breaking, or like you just like have a hard time to just even do the most basic of things with the developer tools or SDK. And so the last part is like, of course, development speed, which we spent a lot of time thinking about, because like the World Engine is a part of Argus, and Argus is not a pick and shovel company. We are a game studio at the same time as well. So we want to make sure that our game studio, like the game developers that we have at Argus, are able to create a new game as like fast as possible without having to worry about these like additional complexities that you would have, or like the struggles that you would have from building on-chain game without the World Engine, right? And so this is like why we built our like robust developer tooling ecosystem, where we have the Cardinal editor, which is like the one that you see on the left, and a World CLI that you see on the right. So the World CLI allows you to spin up a new game shards in like 3 minutes. You like literally just install the World CLI and then type in world create. It initializes a new game shard repository for you with all the basic boilerplates available. And like from there, you already have a functioning game shard. There's nothing you need to configure. It already works. It already runs for you. All you need to do is literally just like implement your game logic and like make calls with it using the Cardinal editor, which is the one on the left, which allows you to inspect the game state. It allows you to actually see every single state transitions that is happening within the World Engine and actually make calls directly to it without having to write your your game client yet. So you can focus on just like prototyping using the Cardinal editor. And one of the things that is actually really interesting is like the way that we actually prototype new games internally at Argus is by using the Cardinal editor before we even start building the game client, building like let's say like the front end. We literally just use the Cardinal editor to basically be like kind of these like kind of like almost a simulation, or like kind of like a way for us to play the game before actually building it fully, building out fully. And that speeds up the iteration speed significantly, which if you are a game developer what you would know is like one of the things that you would have to worry about the most, because you want to make sure that you're like experimenting with the mechanics that are fun, that are engaging to the players. And that is like developer tooling ecosystem that we maintain, and we push out updates almost like every week, to make sure that we have like new features and we solve like, these different pain points that game developers have when they're building with the World Engine. And again, last but not least, of course, is the game engine integration itself. One of the things that I feel like I was like complaining about a lot when I was like building Dark Forest with my friends was that there's not really any easy way for you to connect Unity or Unreal to, like, let's say the Ethereum blockchain or like an EVM blockchain. Most of the toolings or like that you have in like, these blockchains are JavaScript, because most people are only using like, web apps, right, to like interact with their smart contracts. Well, this is, of course, is a problem for game developers, because game developers have like these like specialized toolings that we need to actually make, like, let's say a 3D game. You can't make 3D games easily on only JavaScript, but you actually need a proper game engine to be able to support things like shaders, to be able to like control like player inputs, like cameras, etc. And so we thought like, hey, like, why do we have to invent the wheel here? Why do we need to like get people to like, like give up Unity or Unreal or like whatever programming language you want to use, just to be able to build a fully engine game? And that's like why we make sure one of the things that we do when we're building the World Engine is that we have integration for all the major game engines. And so like if you're building on a World Engine today, you can immediately hook it up to Unity, Unreal, Godot, or if you still want to use JavaScript, you can also use JavaScript, C#, Dart if you use Flutter, and like so on and so forth. We have so many of these SDKs built out so that you can integrate with any kind of a client side kind of like front end that you want, and that solves so much headache as a game developer. And like the amount of time that I've saved in just like being able to like build my game client in Unity instead of just JavaScript is enormous. And so if you are building your game and you don't really have a specific stack and preference, I really recommend checking out these game engines that is really easy to learn. Like if you actually haven't learned Unity or like any game engines before, I would highly recommend checking out Godot, which is like an open source game engine that has these like Python-like programming language called GDScript, which again, really, really easy to learn and speeds up your like game development so much faster than you would if you would like have to use like, JavaScript to like, build everything from scratch. And so like, yeah, that's like the key thing that you will be able to have by building using the World Engine. And so by using World Engine, we have been able to create a lot of really, really fun games that some of you might have been able to try out before. One of them being Dark Frontier, which is this like refresh of like, spiritual successor or like spiritual reboot of like the Dark Forest, where we launched this on Celestia last year and had like thousands of players creating like hundreds of thousands of like transactions during the span of a week where we were running it. And it also uses this zero-knowledge proof cryptographic fog of war, which we also have an integration for the World Engine. So if you are interested in experimenting with using zero-knowledge proof for your game, let us know, and we would be able to point you in the right directions on how you can integrate zero-knowledge proof as well to your game. We've also seen real-time games being built using the geolocalized shard system that we have with the World Engine. One of them is called Gravitation.io, which our partner game studio Evolute have been building. And so with Evolute, what they needed was a real-time like blockchain that is able to support the number of transactions that they have and to make sure that every single players have low latency, and they have to use the World Engine. Like it was like not possible to build their game anywhere else because of the sheer number of transactions that they're making, which is like on the same level as like a Gar.io, which again is like really kind of the closest comparables that is like can be made here for the game. Again, it also scales horizontally using the World Engine, so you can have these like independent rooms and like compartmentalized into different shards with the World Engine there. There's also like puzzle games like Arcane Reveal, which is inspired by this like very fun mobile game called Cinco Pas that only like for some reason is like only available in Turkish. And so like if you're like like brave enough, you can play this like really nice puzzle game called Cinco Pas on your mobile phone. And again, we try to build something similar on the World Engine as well, in collaboration with Seismic, using their private compute framework that allows you to have like fast time to action by eliminating the need for client-side ZK proving while saying like still using the private hidden states that we have. And like, yeah, and all of these like developers choose the World Engine for 3 simple reasons. The World Engine is designed from the ground up for game developers by the game developers. So you don't have to worry about the blockchain headache. That's fully abstracted by the World Engine. We have the best in class developer tooling. And these developer toolings are not designed for like DeFi or whatsoever. It's literally only can do games. And that's like why it's like so powerful, because we know exactly what they're going to be used for. And we also try to make sure that we can make the experience of building a game as fun as like playing it. And last but not least, of course, is to make sure that game developers never have to worry about scalability and latency again. Because the worst nightmare is telling your boss or telling your like, I don't know, telling your users, your players that like, hey, I'm sorry, you can't play the game because we don't have enough space on a blockchain. With a World Engine, you don't have to worry about that because we have horizontal scalability, which is again very much expected if you're building a game server, let it be on-chain or not. And so like, yeah, with all that being said, you can start building on the World Engine by visiting world.dev. We have a very easy to follow quick start guide there that takes you less than 5 minutes to follow, and you would have a working game shards like by the end of it. And then yeah, if you have any questions about building on the World Engine, we'll be on the Discord. Feel free to reach out to the mentors. And like, if you ever want to just like chat or want to brainstorm about your game, if you like, just like, I don't know, just want to talk about random stuff, I'm also on Twitter. So feel free to like reach out, just look up my name at SM Sunardo. And I'm happy to hop on a call with anyone who just like jam, or like if you just want to talk about like how it's like running a game studio, right? How it's like to be running a blockchain company. Always happy to just jam with cool people. And like, yeah, that's pretty much it for today. And again, you can follow us at ArgusLabs _ and worldengine.gg and like world.dev for the documentation for the World Engine. Thank you.
Thank you very much, Scott, for running that really, really interesting tutorial and really in depth as well. So I'm sure everyone is going to find that really useful. The recording of this tutorial will be posted tomorrow. So don't worry if you missed anything, you can catch up. We'll end there for today because we're coming to closing time. But tomorrow we have a slightly longer tutorial because we have 3 different companies running their tutorials within one slot. So that is Astria, Forma, and Happy Chain are all presenting their ideas. The information is all in the calendar invite that you should have. So if you're interested in those, then all of them are happening tomorrow at the same time. So I hope to see you all there. Thank you very much, Scott, for coming. And I think Anirudh has left now, but we also thank him for joining us. And I hope you all have a nice rest of your days, and we will see you very soon.
All right. Thanks, everyone. Thanks for coming.